which is angles of polygons. So we're going to be looking at how we can find the measure of interior angles of polygons and exterior angles of polygons. We've got a little review, which we kind of have already done, some terms, examples, and practice. So, review, convex versus concave. Convex versus concave. Can anyone give me, maybe it would be easier, what's an example of a shape that is convex? Or do we know any shapes that are convex?
Boomerang?
What?
No,
Let's say arrow.
boomerang.
Oh, what'd you say, Hilton?
Boomerang.
Boomerang. You're thinking concave also. Well,
A square!
a square, there we go. A square or a triangle or a, what can I draw it? Decent. Now, concave, remember it's caving into itself, would be like an arrow. Or a boomerang, which I can't draw. But yes, a boomerang would also be concave because it caves in. So they're gonna, the words convex and concave are gonna come up again in our homework. So we just want to be aware of what those are. Now, a little bit of vocab before we get into a formula. And this is not something that you have to necessarily write all of this down, but the main thing is you need to know what the term diagonal is, okay? So when we create, well, I guess they did it for us in the warm-up, when they created these triangles, all these dotted lines, well, would all of them be? Yeah, those dotted lines would be considered the diagonals, okay? The formal definition. In a polygon, two vertices that are endpoints of the same side are called consecutive vertices, right? Consecutive vertices, two vertices that are endpoints of the same side. So B and C would be consecutive vertices. A diagonal of a polygon is a segment that joins two non-consecutive vertices. Okay? So, like, BA would not be a diagonal because those are consecutive vertices. So, if we had to create or fill in the diagonals from point A, what points would they go to? We had to draw the diagonals that go from point A. What point?
C to E.
C? What's the other one? D. Yep. It goes to the 2 points or the two vertices that are not connected to it, that are not consecutive. Okay? So diagonal is just those connecting lines. Now our diagonal forms what? When we put our diagonals from point A, that forms our triangles. Okay? So that term isn't going to come up a lot, but we still want to define what those lines are. So it's a line that connects non-consecutive vertices. Now we have our theorem. I mean, we went over this. This would be the third time now, from the Kahoot to the warm-up to now. But the sum of interior angles of a convex n-gon, so that's the fancy way of saying like pentagon or any of those, heptagon, whatever type of gon we have, is n minus 2 times 180. Notice that it has to be convex. So we couldn't apply this term to like the arrow or to the boomerang. But n minus 2, n being our number of sides. So if we had this shape here, it's got 6, 1, 2, 3, 4, 5, 6 angles, minus 2 times 180, and that would give us, whatever that multiplied out to be, would give us the measure of So if we were given this problem, find the sum of the measure of the interior angles of the figure. We have 8 angles. 8 minus 2 times 180. 1080 degrees. Questions on this first theorem, 7.1? Now you could also see that they would work this in the other direction. So in this case, they're going to say that the sum is 900, and we need to figure out what type of polygon it is. So we know the sum is 900. We know that we can get to 900 by going n minus 2 times 180. What would our first step be to solve? Divide by 180. So 900 divided by 180 is, someone's going to have to put that in the calculator. I don't know off the top of my head. I have it written down. But I can't see it from here. What is it? 5? Add 2 to both sides. So what is a 7 heptagon? So then we would classify our polygon. It might not be a bad idea, and I can put a list up there. I don't have one in the slides, but it might not be a bad idea to write down in your notes, like a 3-sided polygon is triangle, 4-sided is blank, 5-sided is blank, 6 and have up to like, I don't know, 10 or so in your notes, just so that you don't get a problem wrong because you don't know that 7-sided is heptagon. I mean, those are kind of tricky to keep straight. So I can put a picture of that up. That would be helpful if you want to write that. All right, we have a corollary to this theorem. So does anyone remember what a corollary is? Right, an extension of the theorem. Yep, good. So it's kind of building off of theorem 7.1. So we call it the corollary to the polygon interior angles theorem. I think we need a longer name. The sum of the measures of the interior angles of a quadrilateral. How many sides does a quadrilateral have? 4. It's always 360 degrees. So whether we have a square or like, they would classify this as a parallelogram or a rhombus or whatever 4-sided shape they might give us. The sum of the interior angles is 360 degrees. I'm not exactly sure why they make that into a corollary, because any 4-sided shape, we'd go 4 minus 2 times 180, and we would, I mean, it's pretty clear that's 360. So I don't know why they like state that one specifically, probably because it's the one we use the most, is with the quadrilaterals, but it's worth noting. Our last example. An example of term, one more example, and then that's it for today. Find the value of x in the diagram. So we have, this has 4 sides, right? So it's a quadrilateral. We know that it adds up to 360 degrees. We need to solve for x. And this is something you could see them doing not only with quadrilaterals, but like with a 6-sided figure where they give you, a couple of the sides and don't give you another one, and you need to find what those missing sides are. But 360 needs to equal 108 plus 121 59 plus x will give us that 360 degrees. 72 after we add together and subtract. X will equal 72 degrees. Now we can double check it. If we want to add them all back up again, we need to make sure we get 360. We've been doing this right here with triangles since like a while ago. So now we're just extending it to shapes with last couple of terms. And these terms are familiar to us already, because we did equilateral triangles and equiangular triangles. But now we're just extending it to polygons. So an equilateral polygon means that all sides are the same. All right? Equiangular polygon means that all the angles are the same. The last term, a regular polygon, first thing is convex, but also it's both equilateral and equiangular. A lot of times we'll be working with the regular polygons. They're both equiangular and equilateral, but not always. So we already know equilateral, we already know equiangular, but I don't think we had a regular triangle. Last example. The whole play for a baseball field is shown. Is it a regular polygon? Or is a polygon regular?
No.
Yes or no?
No.
No? Why not?
Because not all the angles are the same.
Right, not all the angles are the same. We have a right angle here, and then we have some other angle that we don't know right there on angle E. Good. Find the measure of C and E. C and E. So, how many degrees does this home plate have to add up to?
1, 2, 3, 4, 5. 540.
Well, it amazes me that after our conversation yesterday over email, that you're looking at other things in the West. You're looking at the stocks. What are you talking about? After your email yesterday, that just absolutely blows my mind. And there's a reason. I mean, you know where I'm coming from? Do you need me to keep going or not? Okay. 3 times 180 gives us what? 540. So we know that the interior angles have to add up to 540. How many of those angles are right angles? 3 of them. So how many degrees does that take up? 270. So we know that 540 has to be 270, and then let's just call angle E and angle C 2x, right? Do you see where that 2x is coming from? Angle E and C have to be the same. We just call them x. There's 2 of them.
Angle B and C.
What questions do we have? No questions? That's all. Tomorrow we're going to talk about exterior angles, and that will just be a couple slides. But today we're just going to stick with the interior angles, and the worksheet will just be I think it's just the front side. Maybe 1 or 2 questions on the back side. Let me take a look. But I've got a worksheet that we will start.